So when we do time complexity analysis, typically we say we are measuring number of times instructions in a given function run. So that's the count that we do, and with that count many a times is expressed as a formula. So we will talk about two types of complexities. One we say is practical. So practical is like counting each and every instructions. That is practical. And second that we talk about is asymptotic. Right? Asymptotic is something we'll get into what it is. But keep in mind there are two types of complexities we will talk about right now. So expressions using built-in operators in single instruction. So imagine if I say there is an expression C is equal to A plus B minus D into 10. So can I say this is one expression which is doing some calculation? If our code has one line like this, it's one statement, we will say this is counted as single statement. Even if it had few more parameters, plus 9 into F minus 6 into C, this we will treat as one instruction. This makes sense? The number of time instructions in a loop run, if there is a loop running 10 times, how many instructions we will count? 10. Ideally, in a loop, if you see, first we know assignment happens. Second, where does the control go after assignment? Conditional statement. It validates. So far if you see there is one for assignment, one for comparison, then you go and run this instruction. So this instruction is going to run n times. After this instruction is run first time, it will do I++. Then again it will check this. So when we talk about loops, we will not worry about assignment, comparison, this. What we will do is we will worry about the instruction that is there inside the loop, how many times that is running. So we will focus only on that. So this is to simplify the analysis that we are doing. If there are two sequential loops in your function, first loop runs and second loop runs, then what we do is number of times instruction in the first loop run plus number of time instruction in the second loop run, they both add up. Right? It's like if I say I'm giving you two boxes, both full of chocolates. First you have to finish the first box, then you have to finish the second box. If first box has 10 chocolates, second has 9, total how many times you will be eating the chocolate? 19. If I say there are 10 rooms, each room has 9 chocolates in it. So you go to first room, eat chocolates, go to second room, eat chocolates, third room. In this case, how many you will eat? If there are 3, 27. If there are again 10 or 9, it will be multiplied with that, right? So this is called nesting. This is called sequential. So when we have two sequential loops, they add up. When you have nested loops, a loop inside loop, you are saying for first room, go and eat everything. For second room, go and eat everything. So that nesting wise, we multiply. Right? So we have few examples written in front of us. And if we want to do the time complexity analysis, imagine these loops are written inside a function. And when we are doing time complexity analysis, we are analyzing the time complexity of a function. So how many times this instruction will run? N times. Clear? If I was 0, if we start I with 0, then it is n plus 1 times, right? So when I say practical time complexity, we say we will do proper calculation how many times it runs exactly. Asymptotic says n plus 1, reduce it to n. Remove this plus 1 and all. It's like chiller, we don't care about. Right? If some item is 1001 rupees, we say okay, it is 1000 only. So that's the asymptotic thing that comes into play. That practically you count even single instructions. Asymptotically you leave that low order bit out. So first one.
Asymptotically means you will not take something which is more than like 1 plus 1.
Yeah.
That's what asymptotic means.
Yes, that's what it means. And we'll talk about what the purpose of asymptotic is. Why do we want to do asymptotic? Right? Yeah, but that is what it means essentially. Second one, if I talk about, tell me what is the practical time complexity. If these two loops were sequential inside a function, what is the practical time complexity? First loop is running n times, second one m times or m plus 1 times. m plus 1, because 0 is also there, m is also there. If m was 4, it is running for 4, 3, 2, 1, 0. So it is n plus m plus 1. This is practical time complexity. And asymptotically, of n plus m. Right? So we are leaving that one aside. Third one, what is the practical time complexity of this?
n into m.
Running n times. So can I say n into m plus 1? Is that correct? No, this is not correct. Mathematically, it is not correct. I should say that. Yeah, it should be like this. Right? N into m plus 1 versus they have different meanings because of the board mass. Right? Okay. So we are clear. Basic analysis, this is how we do. So we will look at some more samples like this, and then we will go into some actual interview questions, and we will think of an approach. We'll come of another approach. We'll compare those approaches. That's how we will align our discussion. Right? So this much basic is required, and an introduction to what is asymptotic is required.